Namaste, welcome to Pythagoras Academy. This video is about drawing a perfect free body diagram. When it comes to mechanics, drawing a perfect free body diagram is essential to get your analysis right on a given scenario. So let us try to understand the steps that one should follow to draw a perfect free body diagram without any misconceptions. The whole aim of this video is to clear off the misconceptions that students have while drawing a free body diagram. I will try to take a very simple system first to explain the steps, then I'll take some random example and try to draw the free body diagram for the same. Step number 1 is decide the system. Let me take a very simple or the simplest example that there is a body or a block of mass m on the ground. Say the ground is smooth, no friction. An external force F is applied in the horizontal direction. The question is to find the acceleration of the body. Of course, this is a very simple question, but I have taken this example to make you understand the steps that one should follow to draw the free body diagram. Step number 1, decide the system. So system is nothing but set of entities on which you are trying to perform the analysis. So in this particular example, I want to find the acceleration of the block. So I would decide that my system is the block. And step 2, draw coordinate axis. So x-axis and y-axis. And represent the system as point mass at origin. So as far as the translatory motion of the system is concerned, the exact point of application of force does not matter. When it comes to the rotatory motion of the system, then we need the exact point of application of the force in order to find out the torque. But we are talking about the acceleration of the body which is translating. So the exact point of application of force does not matter. So we represent the entire mass of the system that we have chosen to be a point mass at origin. So this particular step will help us to easily look at the free body diagram and understand different forces acting on the system. And step 3, identify all external forces. This is to be observed. We are not bothered about the internal forces. When we choose a system, there can be several internal forces acting on the system. But as far as the free body diagram is concerned, we are only interested in the external forces acting on it. And that too, the keyword is on. There can be some forces applied by your system, and there can be some forces which are acting on the system. And as far as the free body diagram is concerned, we are only interested in all those external forces acting on the system. On is the keyword. This is the place where most of the students will go wrong. In the free body diagram, they'll also try to represent the forces which are applied by the system. Then the entire analysis will go wrong. So on the system, just identify the forces. Because the body has got mass, there is weight acting on it, and the direction of weight is mg downwards. Because the block is in contact with the ground or the surface is always exerting a pushing normal force. So there is normal force N acting in the upward direction. So N upwards and mg downwards. So I could only observe these two external forces acting on the system because the surface is smooth, there is no friction. So identify all external forces acting on the system and represent with proper directions. So I have represented. Coming to step 4, resolve all the forces acting along and perpendicular to the line of acceleration. So the system would definitely accelerate towards right in this case because the system is on a horizontal surface and there is some external force in the horizontal direction applied. And I should also represent that external force F which is applied. There are 3 forces, mg downwards, normal force up, and the applied external force F. So this is also external force which is acting on the system. So the system would accelerate towards right. Now step 4 says, resolve all the forces acting along and perpendicular to the line of acceleration. So identify the line of acceleration. In this particular simple case, the system would accelerate along horizontal. So the line of acceleration is horizontal. Now resolve all the forces along and perpendicular to line of acceleration. Coming to normal force, it is already perpendicular to acceleration, so there is no necessity to resolve this again. And mg is already perpendicular to acceleration. The force F is along acceleration. Because this is simple case, so the step 4 is not useful here. The forces are already resolved along the line of acceleration. And coming to step 5, apply Newton's laws and get equations to solve. So applying Newton's laws, Newton's second law, net force is equal to mass into acceleration for a constant mass system. Because this is a constant mass system, in the vertical direction, what is the net force? N minus mg. I'll take upward as positive, downward as negative. Net force is n minus mg. That is equal to acceleration in the vertical direction 0. So n minus mg is 0. This is the first equation that I'll deduce. Second equation in the horizontal direction, net force is F. That is equal to mass of the system into acceleration of the system, ma. So this is the second equation. From the first equation, I can find out the force applied by the surface on the body, which is N equal to mg. So the surface is applying a force which is equal to mg on the body. Normal force is not equal to weight. Magnitude wise, normal force is equal to weight, and normal force is acting in upward direction, and its magnitude is equal to the weight of the body. And similarly, from the second equation, I can calculate the acceleration, which is F by m, because F is equal to ma, a is equal to F by m. So this is the simple example. Now let us take another example to apply the steps that we have just discussed. Say there is a block of mass m1 attached to a string, and then m2. Now I am drawing the free body diagram. The intention of this problem is to find out the acceleration of m1 and m2, given that the surfaces are smooth and the pulleys and the strings, whatever they are, they're ideal. Light and inextensible strings, frictionless and massless pulleys. So this is a fixed pulley. In this case, if I have to draw the free body diagram of m1, so my system is m1 now. I have decided the system, drawing the coordinate axis, m1 as point mass, the forces acting on the system, m1g down, normal force up, and tension T, and say this is accelerating towards right. And on m2, it is m2g, and the tension T, because it is attached to the string, T is upwards. And if you observe, I am only interested in those forces which are acting on the system. So T is acting on the system, tension is always a pulling force, and this is accelerating downwards. Now if you write the equation, n minus m1g is 0 in the vertical direction, and in the horizontal direction, net force is T, that is equal to m1 into a. This is equation 1. Even in this case, resolution of forces is not required, because all the forces are already along the line of acceleration and perpendicular to line of acceleration. From the second free body diagram, net force is m2g minus T, which is equal to net force mass into acceleration, m2 into a. Second equation, solving these two, adding these two, T is gone, m2g is equal to m1 plus m2 into a. So a is equal to m2g by m1 plus m2. For example, if you have an inclined plane and there's a block of mass m placed on the inclined plane, this is smooth, and if you are interested to find the acceleration of the block down the plane, then draw the free body diagram of the block. The system is a block, and I have represented as a point mass taking the coordinate axis. Then what are the forces acting on it? The forces acting on it are mg downwards, its own weight, and it is in contact with the inclined plane, so there is normal force. So draw a dotted line of the inclined plane so that the directions of the forces will be clear. So this is theta. The inclined plane is making angle theta with a horizontal. So if this is theta, this would be theta, and this is 90 minus theta, and this is theta. Now the acceleration of the block is down the plane. Coming to step 4 now. Resolve all the forces along and perpendicular to line of acceleration. So I would resolve, now there is no confusion. So most of the students are confused when they draw free body diagram of which force to resolve, whether in this particular case should I resolve normal force or should I resolve mg. The point is very clear. You have to first identify the line of acceleration and resolve all the forces along and perpendicular to line of acceleration. So line of acceleration is down the plane, normal force is already perpendicular to line of acceleration, so I should only resolve mg. So perpendicular to line of acceleration, the mg has got the component of mg cos theta. Along the line of acceleration, it is mg sin theta. Now applying Newton's laws and to get equations to solve, along the perpendicular to plane, net force is 0. So n minus mg cos theta is 0. This is the first equation. And along the plane, net force is mg sin theta, which is equal to mass into acceleration, because according to Newton's second law, for a constant mass system, net force is mass into acceleration. Net force is obviously mg sin theta, which is mass into acceleration. So from the second equation, I can solve to get the acceleration, which is g sin theta down the plane. As simple as this. So I've taken very simple examples just to demonstrate how to draw a perfect free body diagram. So free body diagram is not just this. There is another concept that you should know while drawing the free body diagram. If you identify a system where some pulleys are attached to the block, then there is one more important thing to be noted. And to know that, I'll cover that in the next video. So please do follow me. Thank you.